In auto transformer, let us solve the problem. Okay, let me solve first generic problem, and after that, each and every problem of old gate or previous years questions we will see. For example, my transformer given is two winding transformer. So this is two winding transformer. I would like to convert the two winding transformer into auto transformer. Basically that rating is, for example, 250 volts by 2500 volts, 10 kVA transformer. Okay, I would like to convert this into auto transformer. For example, as auto transformer. Okay, in our previous session we discussed about what is the transformed power, what is the conducted power. Now let us calculate for that. For example, if I have, okay, so dot here, polarity test, and if I have dot here, okay, at starting a small confusion will come, but automatically clarity you will get. Okay, for example, dot in the sense when this dot is positive, automatically this dot will become positive. So for example, this is plus minus HV side 2500 volts, means that this is going to be LV side. Whenever this dot is plus, automatically this dot will become plus. So this is going to be 250 volts. Okay, means that at the input side, how much voltage I have to supply? 2500 volts. And the output side, how much voltage I am going to get? 2750 volts. Now few guys will get it out. Okay, is it possible to convert a practical transformer into auto transformer? Yes, it is possible. For example, if I have practical two winding transformer, in practical two winding transformer, for example, this is the windings. Okay, so this is just by number of turns or more. So this is going to be HV, this is going to be LV. How to keep the dot convention? Basically this particular iron is there, upon the iron wire is there dot. Where dot has to be kept? This is the iron, so upon the iron wire is falling, so this is going to be dot. Okay, so when this is plus minus, when this dot is plus, let me think of 2500 volts. Whenever this dot is plus, automatically this dot will become plus. So this is going to be 250 volts. Now how to convert this? How to convert this into auto transformer? For example, dot of 2500 is getting connected to undot of 250. So dot of 2500 we have to connect to undot of 250. Okay, now dot of 250 is coming out. So dot of 250 is coming out. Now undot of HV, undot of HV is going to be the output. So undot of HV, this is dot of HV, undot of HV is going to be the output. So how much will be this voltage? 2750 volts. Because if you try to apply KVL, this voltage equal to plus 250 plus 2500 is going to be 2750 volts. Okay, now let us see how to calculate load currents. Okay, for example, as a two winding transformer, it is designed for 10 kVA 250 by 2500 volts. Okay, so let me calculate as two winding transformer full load current under LV side. Okay, how much is full load current under LV side? 10 kVA divided by 250 is going to be 40 amperes. Okay, how much will be the full load current under HV side? 4 amperes. 4 amperes because turns ratio is 10. Okay, now for example, if you think of here, this winding is designed for 4 amperes HV side. Okay, so this winding, for example, this winding current is in this direction, this is going to be 4 amperes. Okay, already we know that in two winding transformer, if one of the winding current enters into the dot, another winding current should leave from the dot. That is the transformer principle. So if I take in this direction, this current is entering into the dot. Okay, so it is entering into dot, and after that it is entering into winding. So here it has to leave from the dot. Means it has to enter into undot and winding, and after that, after winding from the dot, it has to leave. So current should be 40 amperes here. Okay, so how much current it will take here by KCL? 4 amperes is flowing here, 40 amperes is flowing here, so 44 amperes it will take. Now let us map this to here. For example, if I think of 44 amperes is flowing here. Okay, so in this HV 4 amperes will go. Okay, so current is entering into dot, so remaining here 40 amperes will flow. Okay, so remaining 40 amperes will flow, 40 amperes will come here. Okay, such that whenever my current is entering into dot, my current is leaving from the dot or not? Yes. So let us think of what is the total power input. So for example, S of total equal to V1 I1 or V2 I2. Okay, how much is V1 I1? 2500 into 44, or we can say 2750 into 40. Okay, so total power output equal to total power input is going to be 110 kVA. Right, now let us calculate S by transformer action. S by transformer action. S by transformer action is nothing but means total power handling capacity of either separate winding or combined winding. Now where is combined? 2500 is combined between primary and secondary. And what is separate? 250 volts is going to be separate to secondary only. So S of transformer action in the sense combined or separate. Okay, what is combined? 2500 into 4. Or we can say 250 into 40 is going to be 10 kVA. Okay, let me think of S of conducted power is nothing but S total minus S of transformer action. So is going to be 110 minus 10 is going to be 100 kVA. Okay, so out of total 2 winding transformer of 10 kVA capacity, the same transformer if you change like into, if you convert itself into, for example, as an auto transformer, means auto transformer can be used up to 110 kVA in this configuration. Okay, what is this configuration? We are going to call this as aided configuration, because input voltage is 2500, output voltage is more than 2500. Okay, so this is going to be aided connection. Okay, now our additive connection we can say. Additive connection. Now for example, let us think of subtractive connection. In subtractive connection, if they give the same problem, how to solve? If we see, for example, if you connect this here dot, okay, so here for example this is 2500. Now whenever this dot is positive, another winding dot should be positive. So positive, negative is going to be 250 volts. So how much will be the output voltage? Is going to be here 2500. Here 250 is going to be 2250. Okay, so compared to input voltage, output voltage is reduced or not? Yes. So if we compare input voltage, output voltage is reduced, means that it is going to be subtractive polarity. Okay, now let us calculate currents here. For example, my 250 volts winding is designed to carry 40 amperes. Isn't it not? For example, as a 2 winding transformer, 10 kVA is the total power handling capacity, and LV side voltage is 250, means that 10,000 divided by 250 is going to 40 amperes. So my 2 winding transformer is designed for 40 amperes. Now if I consider 40 amperes here, my current is entering into dot or leaving from the dot? My current is entering into dot, and after dot it is entering into winding. So here this current should leave from the dot. Okay, now if this current is 40 amperes, how much will be this current? 4 amperes. Okay, so if I try to apply KCL here, 40 is leaving, 4 is entering, so this is going to be 36 amperes. Okay, now let us calculate S total. S total equal to V1 I1 or V2 I2. Okay, V1 I1 is 2500 into 36 or V2 I2 2250 into 40 is going to be 90 kVA. Okay, now let us think of S transformer action. is nothing but S of combined between primary and secondary, or S of separate only to secondary. Okay, so S of combined is going to be 2500 voltage multiplied by current flowing through this is 4. So 2500 multiplied by 4, or we can think of 250 into 40 separate, because this winding is going to be separate on HV side only. So 250 into 40 is going to be 10. Now what is S conducted? S conducted is going to be 90 minus 10 is going to be 80 kVA. So 80 kVA is being transmitted from here to here because of direct electrical connection, and 10 kVA is transformed here from here to here without lack of or without having any electrical connection. Okay, now let me think of, for example, like different things we can do. But anyway, if they give as a two-winding transformer, for example, as a two-winding transformer, if they give efficiency at full load, for example at UPF is 95%. In that case, how to calculate for full load efficiency as a auto transformer? Now here, okay, can I calculate losses as two-winding transformer or not? Yes. So let me calculate losses as two-winding. Is going to be 1 by efficiency minus 1 into output. Okay, so what is 1 by efficiency is going to be 1 by 0.95, because 95% efficiency they have given, minus 1 into what is output as a two-winding transformer? Full load. Okay, so if it is full load capacity is 10 kVA. So 10 into 10,000 full load into unity power factor. Okay, losses roughly you will get, I think, 525 roughly watts. Okay, now means just if we see as a two-winding transformer and auto transformer, actually if you guys will be confused here. Okay, as a two-winding transformer and as auto transformer, losses we are going to consider as constant here. Why? Because in transformer, what are the types of losses? Core loss will be there, copper loss will be there. Okay, core loss will be decided by the voltage across the windings for a given frequency, of course, and copper loss will be decided by the conductor currents. Okay, for example, if I think of here additive polarity means as a two-winding transformer, forget about this red line, as a two-winding transformer, how much is the applied voltage here? 2500. How much is the voltage existing across this? 250. Okay, as a two-winding transformer at full load, how much currents will flow through the winding? 4 amperes. At full load, how much currents would flow through these windings? 40 amperes. Now forget about two winding, let us come back to auto. As auto also, how much voltage is appearing across this? 2500. How much voltage is appearing across this? 250. So core loss should be same. Okay, see here across this winding 2500 volts is only appearing, and across this winding only 250 volts is appearing. So voltages are same. So core loss will be same. Okay, now if you think of as a two-winding transformer full load currents and as an auto transformer full load currents are same, so copper losses also will be same. Okay, so as a two-winding transformer and as a auto transformer, okay, if you convert two-winding transformer into auto transformer, if you operate at the rated conditions only, losses will be same. So here losses as a two-winding equal to losses as auto equal to roughly 525 watts. Now let me calculate efficiency as auto at full load at UPF equal to how much? Output by output plus losses. How much is the output here? 110 kVA. So 110 kVA unity power factor divided by 110 kVA unity power factor plus losses are two winding and auto will be same. So this is going to be 525, means roughly 98 or 99% is going to be the efficiency, efficiency will come. Okay, for example, in subtractive polarity, if they ask efficiency, for example, how much will be the efficiency as auto at full load unity power factor equal to, in subtractive polarity, what is the output kVA? 90 kVA. Okay, so this is going to be output 90 kVA into unity power factor divided by, okay, 90 kVA into unity power factor plus what are the types of losses? 525 watt. So you are going to get efficiency here. Okay, so point here is very simple. In additive polarity, net output power is going to be more. In subtractive polarity, net output power is going to be less. So actually one more question they will ask in GATE exam: what is the maximum power handling capacity for a given transformer in auto transformer? For example, see here, in between additive and subtractive, means my additive is going to get more power handling capacity. Here 110 kVA, here 90 kVA only. Okay, now for example, see here, if I keep 2500 volts here and if I keep 250 volts here, okay, so if I keep 2500 volts here and if I keep 250 volts here, under that condition, what is output voltage? 20 to 50 only, it don't change. But the moment if I keep 2500 here, how much maximum current can flow through 2500? 4 amperes only. Okay, then output capacity is reduced or not? For example, in additive polarity only, so additive. For example, if this is 250 volts and if this is 2500 volts, so how much is the output voltage? Output voltage is going to be 2750 volts. Did output voltage change? No, and it is like additive polarity only. So output voltage will be same, but if you think of current flowing through this, okay, if you think of current flowing through this, how much maximum current can flow through HV winding? HV winding 2500 volts. 2500 volts HV winding is designed for 4 amperes only. So 4 amperes only. So 4 amperes into 2750. So S total equal to 2750 into 4 is going to be 11 kVA. So in this case, 10 kVA will be the transformed power. Only 1 kVA is going to be the conducted power. Okay, so point is very simple here. In auto transformer, how to calculate efficiency and all we know. Okay, for example, if they ask maximum power handling capacity of the auto transformer, means that two things we have to remember. What are those two? First thing is condition should be polarity, should be additive polarity, and second thing is separate winding should be LV winding. Because if separate winding is LV winding, if I keep 250 here, output current is going to be 40 amperes. So two conditions are there. One is additive polarity and second thing is LV winding should be separate winding. Okay.